Good morning, everyone. I'm Seung-ho Choi as presenter. I'm currently working at the Affiliated Institute of Actuary in Republic of Korea. What I'm going to talk about today is expansion of ICS Testbed for security validation based on MITRE ATT&CK techniques. Let's begin. I will divide the presentation into 6 parts as following contents. I'd like to start by asking you a question. How can we achieve continuously monitoring all levels in the ICS with MITRE ATT&CK framework? For this, ICS environment that allows ingesting and analyzing various datasets to gain security visibility is needed. But there are still questions. What is the data needed for monitoring? Where can we get the data from? How can we data be obtained? Of course, data obtained from the actual operating environment are ideally suited. However, actual data are difficult to obtain from ICS operating environment owing to availability. Even if the data are available, a lot of information must be deleted or modified owing to confidentiality. Existing testbed and dataset mostly include network traffic or operation information because attack scenarios typically target a specific area. When validating and testing security systems, obtaining attack-related data is challenging. To overcome limitations, we focused on 3 factors. First, we selected monitoring fields to detect security threats that was achieved by analyzing the MITRE ATT&CK framework. Second, we expanded high testbed to collect and process the fields based on the MITRE ATT&CK framework. Lastly, for availability of controllers and data collection periods, we consider dataset enrichment to improve dataset scalability in various attack scenarios and to modify previously collected datasets. This slide outlines the framework to expand testbed and dataset containing the monitoring fields in our research. We added attack tools to reproduce attack scenarios to high testbed, and also set up virtual environment which is similar to high testbed. We applied port mirroring to the network switch of the testbed as surveillance network traffic. To forward the mirroring traffic to each security appliance, we deployed an aggregator. Security monitoring system allows ingesting and analyzing various data to monitor the testbed. In addition, a data enrichment tool, DET, is proposed to create a dataset for simulating large-scale and long-term attack scenarios. Let me go over background. We built the high testbed implementing real control systems that are widely used in critical infrastructure. To test the process of individual control systems, feedback is acquired by interacting each control system based on the DSpace Hill simulator. High testbed also provides a physical attack tool that can configure and reproduce possible attack scenarios using the process control loop as the operation changes. The MITRE ATT&CK framework is a threat knowledge database that contains tactics and techniques utilized by attackers based on real-world observations. When the MITRE ATT&CK was announced in 2013, it mainly focused on enterprise environments. In the MITRE ATT&CK for enterprise, tactics and techniques were described. Recently, it has been changed because techniques have divided into sub-techniques to specifically describe adversaries' behavior. The MITRE ATT&CK framework has been widely used in several studies regarding adversary emulation, red teaming, defense gap assessment, and so on. Further, the ATT&CK framework has been continuously expanding its domain to industrial control systems. We classified categories for an event of interest hereinafter EOI that is obtained from various data sources. First, the network EOI includes network traffic information collected using port mirroring or tapping. Second, the system EOI includes event information generated by systems such as security appliances and network equipment. The data also covers all the information generated within the host and server. Finally, the physical EOI include analog and digital signals that are generated during the control of field devices, such as sensors and actuators. In the next section, let's take a look at the monitoring field for MITRE ATT&CK framework. Before extracting monitoring field from MITRE ATT&CK techniques, we set the baseline. We targeted MITRE ATT&CK framework for enterprise to use elastic detection rules using elastic common schema. With the baseline, we firstly arranged 52 MITRE ATT&CK techniques used in 92 elastic detection rules. Second, we classified the data source according to the techniques. We finally identified the monitoring field that could be extracted from the data source and specified additional field, including the collection methods. We listed EOI category, data source, monitoring fields, and collection method according to MITRE ATT&CK techniques as shown in the following table. If the MITRE ATT&CK techniques is also used in ICS, the corresponding ID is indicated in parentheses. The initial monitoring fields are indicated in the italics, and the additional monitoring fields are represented in boldface text. As part of Lizard, here is the example of monitoring fields for T1190. When we want to monitor security threats related to these techniques, it can be seen from the two types of EOI and 16 monitoring fields through the total of data source should be obtained by corresponding methods. Depending on EOI categories, there are considerations for monitoring fields from MITRE ATT&CK framework. Because data sources mainly target servers and hosts, other types of systems are required to determine the monitoring fields. In case of network EOI, when capturing a packet from a server or host, no limitations are imposed on program installation. Contrarily, installing a program on an ICS may be restricted due to availability. So it is necessary to apply port mirroring on a network switch or tapping to passively capture packets. I'd like to turn to other view, that is target domains. MITRE ATT&CK for ICS requires additional data sources which are not used for attack for enterprise. When detecting ICS-specific techniques, the operational information must be used as physical data sources. When selecting monitoring fields from these data sources, it is possible to detect whether the information mode or control logic have been changed. Additionally, schema definition for physical data are required. Now let's move on and introduce how to expand high testbed. We expanded the high testbed with the aim of creating a dataset containing the monitoring fields. Based on the analysis of the techniques of the MITRE ATT&CK framework, we emphasize the key factors. First, when the testbed is expanded, information must be collected from various data sources. Second, data must be collected, processed, and stored as a research purpose. Furthermore, it is possible to search and analyze the stored information for security monitoring with visualization. Third, attack scenarios considered a full attack chain to handle a dataset including all levels of ICS hierarchy. A tool to reproduce the attack scenario is also needed. Finally, data must be free of time shift problems. There can be time differences between devices such as control systems, security appliances, and servers. Strict time synchronization is essential to monitor and analyze for real-time monitoring. This slide outlines the expanded testbed and flow of EOIs for monitoring fields. As shown in this slide, we have built an environment for collection all category of EOI through the expand high testbed that reflects the 4 key factors as I mentioned earlier. We implemented 3 attack tools that take into account the EOI categories. Through the physical attack tool corresponding to control systems, level 0 and 1 included in the high testbed, we implemented 14 single attacks targeting a single physical point and 19 sophisticated attacks targeting multiple physical points. We installed ICS Explode attack to generate malicious network traffic based on known vulnerability between level 1 and 2 in ICS. This tool reproduces the attack situation through packet crafting. In addition, it reproduces denial of service and distributed denial of service attacks. Using the Purple Team attack automation, we built a system-based attack environment for level 2. This attack tool is a post module of Metasploit that reproduces the technique of MITRE ATT&CK framework. A direct attack on assets in the testbed during the operation to create datasets can affect testbed availability. Additionally, if attack traffic is directly injected into the operating and management systems, such as the operating workstation, problems may occur in the system. Recovery to the situation before the attack is also considered. To resolve these problems, we built an X-based hypervisor server to form a virtual environment. A virtual environment is physically separated from the high testbed and similar to the existing operating environment. We installed Bit at the virtual host to deliver various data sources to the security monitoring system based on the result of the MITRE ATT&CK analysis. We deployed an aggregator capable of traffic integration, replication, and distribution to forward the traffic received from each network switch to each security appliance. When the mirrored traffic was delivered to the aggregator, the network traffic was simultaneously forwarded to each security appliance via traffic integration and replication. We built 5 commercial security appliances and 2 widely used open-source network intrusion detection systems, SNOT and Suricata. We configured whitelist-based rules according to the IP addresses of assets in the testbed. In addition, we applied signature-based rules provided by each appliance. We activated the log functions at the appliances to generate an EOI and report it to the security monitoring system. In case of 5 commercial appliances, the EOI is collected via syslog. The others provide the content of log files. The security monitoring system includes a collection module for gathering monitoring fields from various data sources and a process module for normalizing the different field types in a command structure via the ICS. Furthermore, Elasticsearch and Kibana were used for storing the process data and for querying and visualizing stored data. Although we built the expanded high testbed, it still remains challenging to simulate our ICS sites with the testbed alone. Specific scenarios are required that we repeatedly change the settings of the virtual environment and attack tools. Besides, the sophisticated cyber attacks targeting ICS called APT consume a long period of time. To overcome these problems, we implemented the data enrichment tool, DET, as shown in this slide. DET consists of two modules that are EOI augmentation and time augmentation. The EOI augmentation module virtually adds assets on the testbed for the dataset enrichment and generates potential EOI. The time augmentation module inflates the existing expanded high testbed dataset according to the time. It would reflect the characteristic of the APT over a long period of time. In conclusion, we introduced a method to expand the existing testbed so that information can be collected and monitored during an ICS attack based on the MITRE ATT&CK framework. To overcome the limitation of datasets collected in the testbed, we are developing tools to transform and extend the datasets obtained from the testbed according to different user scenarios. In our future work, we intend to develop a dataset including information from various data sources that can be used for security monitoring according to the attack scenarios in ICSs. If you have other questions, please feel free to email me. Thank you for your attention.